it's working. Okay, I have to see, make sure that it's working because sometimes it does not record audio and then I have to stop it. Okay, coordinate system, X, origin, Y, arrows. Okay, -1, so I'm going to use 3 different colors. I'm going to use brown for the left, red for the middle, and I'm going to use green for the right. Just to make sure that if you graph something like this, I cannot give any credit. This is not a function. Okay, so brown, red, green. Okay, -1, 1 over e, that's very difficult for me to, I'm just going to beg you to say that this is the point. Please bear with me. At -1 is 1 over e, I cannot, it's too tiny, right? Well, it's not that tiny, it's 0.333, but I just bear with me. 0, 1, and this must be because of the bracket. The bracket tells me that this must be a full stop, full point. And this is the brown, just the left branch. And I know that this is an increasing function. I would normally graph this, but I have to stop. Where? Right here. Put an arrow, and I'm done with brown. Now I'm in the middle, and this is a linear function. 0, -1, and since this is a parenthesis, I have to have an open point. 1, 0, even if I put it as an open point, which is okay, I will come back and fill it in because these two numbers are the same. This is a linear function with a positive slope. Here it is. Done with red. Now I move on to green. So 1, 0, I fill it in. And E is, so if this is 1, 2, 3, I'm just going to say that E is somewhere here, and it goes up to 1. From this point. How come? This is the natural log function, but I can't. I have to start, or if you want, the left-hand point is this. I cannot go any further. So it has to start here and go into infinity. So by the vertical line test, this is a function. The only point where the limit from either side does not exist is at 0. So limit as x approaches 0 from the left of f of x does not equal the limit of f of x as x approaches right, 0 from the right. And because it's a jump, this is called a jump. And therefore, limit as x approaches 0 from either side is dne. Final step, step number 4. So this was step number 3. And step number 4, I have to identify the range of this function. Anyone who hasn't said nothing so far, can anyone tell us the range of this function? Ethan and Elena and Janelle, anyone who has not said anything, can anyone identify the range for this? RJ?
Would it be from -infinity to 1?
But negative infinity is here. Do I see the graph here?
No.
This is where negative infinity is.
Would it be -1 to 1 or -1 to infinity?
Very good, -1 to infinity. But now tell me, I know you're going to say parenthesis for, or open. Open.
Wouldn't it be open on the other side?
Excellent, because the point does not exist. Great job. Who was that? Thank you, Elena. Good. Excellent. That's it. That's the complete. Now, let's go back for a second because I started talking about this, but I didn't. Okay, so what do they want? Sketch the graph and use it to determine the values of a for which the limit exists. So, to finalize the answer, the limit, so limit of f of x as x approaches a exists for, this is a symbol that I would like you to get used to. We're going to use it again. For all x in the interval negative infinity, infinity, except, one more time, except, I'll explain these symbols again, I will write them down for you, except where? At x equals
0.
Excellent. So now let me explain these two symbols. We're going to use them in the next section. Do you have to use them? No. I'm fine if you say no, I don't want the symbols, but I will put it in writing plain English. Fine. That's fine too. I think I'm on page 4. Yes, I'm on page 4. So this symbol, upside down A, it's a mathematical symbol. And this stands for all. Also, it stands for any. It also for every. This symbol stands for is in or is part of for all x in the interval negative infinity to infinity, which is the domain, except at x equals 0. So please, at least, if you don't want to use them, that's fine, but at least get used to them because I will use them though. Okay, back to our book. I have one more example to look at, and then I would like to talk about these limits, all sorts of limits that we have ahead of us, and that will be the end of 2.2. Okay, so let's take a look at one of the examples that we see, the problems that we see here, 15 through 18. Let me stop for a second and ask you if you have any questions for me. Any questions? Don't wait till I ask if you have any questions. You can always stop me anytime, right? Okay. Any preference here? Sketch the graph of an example. This is not, this problem does not have one answer. It has multiple answers. An example of a function f that satisfies all the given conditions. Okay, I'll choose 17 then. And then you choose the next one. So I have to copy limit of f of x as x approaches -1 from the left. The next one is limit of f of x as x approaches -1 from the right. They say it's 1. Then we have limit from either side of 2, which is 3. F of -1 is 2. And we also have that f of 2 is 1. Okay, I copied those. Okay, and I will say this. To me, this is gibberish. I don't know what it is to you. Before I organize it and put it correctly in a table, I don't even know what this means. Okay. I'm going to start with -1, which is here, and then continue with 2, which is here, assuming this is negative infinity to infinity. F of -1 is 2. So this is, don't erase anything, I'm just making a point. This is taken care of. F of 2 is 1. This is very clear. That is done. Then it says limit from f of x as x approaches 2 from either side is 3. 2 from either side is 3. Done. Limit from the left of -1 is 0. Done. Limit from f of x as x approaches -1 from the right is 1. Done. Ah, this makes sense. So, coordinate system, x, origin, y. And now I'm going to put the points first. This point, -1, 2. This point, 2, 1. -1 from the left, -1 from the right, two from the left, three from the right. Let's check again. -1, 2, correct. 2, 1, correct. Limit from the left of -1, correct. Limit from the right of -1, correct. Limit from the left of 2, correct. At 3. Okay. Limit from the right of 2, correct. 3. This is my example. You can do whatever else. You can put a vertical asymptote here if you want. If you want this side to go that way, you can. If you want this side to go that way, you can. If you want to create a vertical asymptote here, infinitely many answers. But this is what I came up with. This is my example of f of x that fulfills guaranteed all the given conditions. They were gibberish to me. I put them correctly in the order they should have been in, not all over the place, and from left to right, I'm able to graph my example.
Why are you, like, why are lines coming off of some points and not others? Like, if we look at, like, you have your open circles and they're like connected, or they have lines coming off of them. But your closed dots don't have anything.
Because that's what this is telling us. This says that the limit from the left is 0, the limit from the right is 1, but the function value is at 2.
So it's always going to look like that?
If that's what I have. No, it depends. If this side is 2, if this number is 2, then I have to start here. I cannot start at 1.
Right. Aside from like the numbers, like if you have your limits like that, they're going to be really down. I'm sorry, we have a puppy and she thinks
That's
it's
fine.
fun. I guess maybe I'll just wait for the next one we do and maybe something will click.
But what is the misunderstanding then? How should I what?
I guess like I'm just not following why there's some arrows coming off and why some are connected.
But as I said, you can create another function. You can go this way and then this way if you want. But you have to show that the limit from the right of -1 is 1. I have to show this, that the limit from as x approaches -1, function values get closer and closer to 1. That's what this says. I have no choice. This has to show that the limit of the function is 1. That's why it's right here at 1. According to this.
So when it just going off of what she said, so when it just says, like, for example, f of -1 equals 2, those would be standalone points?
Absolutely. That have nothing to do with the limit. Remember, we said that the limit exists as long as both sides go from either side, as long as they go to the same number, but the function value could be here. It doesn't matter. Or
So-
not at all.
The line that goes from -1 to 3, or from -1, 1 to 2, 3, that line doesn't have to connect to that point. It can go anywhere to infinity, correct?
Yes, as I
Or
said,
how
you
do I know
can,
it stops?
as I mentioned, yes, you can put a vertical line here if that's what you want, a vertical asymptote, and then connect somewhere else. But this piece has to go to this point, and this piece has to go to this point, according to the given information. What they do in between, it's optional.
Okay.
So another option would be you have a point here, you have the open point here. You can go to infinity, you can create a vertical asymptote, and then you can create a horizontal asymptote going here. A vertical asymptote on the other side going there. It doesn't matter, but this has to touch here, this has to touch here, because that's what the limit is. That part is mandatory.